Assalamualaikum warahmatullahi wabarakatuh. My name is Midaya binti Marsha. My matrix number is AE180056. So today I would like to explain about the activity 3.3.1 open loop position control in exercise 7 open loop and closed loop position control system. So the first step is construct the block diagram in figure 3.4 using MATLAB Simulink. So here is the block diagram. Okay, second step is key in all the parameter values into the Simulink block. So in the table, here are the parameters that we have to key in the block. Okay, now let's look to the MATLAB Simulink. So here is the block diagram construct by referring to figure 3.4 in the lab sheet, and then the parameters are all key in. Okay, for the next step, we have to check block Simulink by keying input angle value 1 and attenuator gain value into 1, and if input voltage and shaft motor position display show the values, it means block diagram is function. So for the third step, I have to key in the input angle S1 and also the attenuator gain S1. So run the simulation, and then so the input voltage display, this is the value, and the display for speed output is 11.73. So it means that the block diagram is function. So for the step 4, increase step by step value of input angle from 0 till 10 and set attenuator gain 0. Observe the shaft motor position display and what happened to the system. Okay, for the next step is I have to key in the input angle from 0 to 10, and also the attenuator gain to 0. So run the simulation and observe what happened to the display. Okay, at the input voltage display, it shows the value which is 6.111, and for the speed output display, it shows 0. Okay, this is because the attenuator gain block is set to 0. Okay, now we move to the step 5. Okay, step 5 is increase step-by-step value of attenuator gain from 0 to 10 and set input angle 0. Observe the shaft motor position display and what happened to the system. Okay, now we set the input angle to 0, and also okay, the attenuator gain is 0 until 10. Okay, now run the simulation. So observe what happened. So as we can see, input voltage display shows the value 0, and also speed output display shows the value 0. So this happened because the input since the input is 0, so that the output so there will be no output. Okay, next we can move to the step 6, which is set input angle 5, 10 and 360, positive for potentiometer clockwise and also negative for anti-clockwise, and fill in the result into table 3.2. So this is the table 3.2. Okay, first so the value 5, 10 and 360, we can put it here. So for clockwise is positive, anti-clockwise is negative. So now let's look for the input is 5, attenuator gain is 1. So what happened? Okay, run the simulation, and so here is the value appear, which is input voltage display is 3.056, and also speed output display is 58.64. So now we change the value to -5. Estimated gain is still the same 1. So now we run the simulation. So as we can see here, the value for input voltage display is -3.056, and also the speed output display is -58.64. Okay, now we can change it to 10. For the estimated gain is 5. So run the simulation. So this is the value appear, which is 6.111 for input voltage, and also for speed output it shows 586.4. Okay, what happens if we change to -10 for input and the attenuated gain is remain constant? We run the simulation. So as we can see here, the value for input voltage is -6.111, and also for the speed output is -586.4. Okay, I think that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurini Syarafi Mat Zamri. Mathematics kat number 488035 will be explaining to you briefly about the exercise 2 simulation, where this block diagram is constructed for the closed loop position control. So to check whether the circuit diagram is a function or not, we need to set the input angle and the attenuating gain to 1, and then we run the simulation and see that the display for the shaft motor position have a reading. So this indicates that the circuit diagram is functioning. Okay, now I'm going to increase the step-by-step value of the input angle from 0 to 10, and then set the attenuating gain to 0. And then we can observe the shaft motor position and the system. Okay, see the shaft motor position show no reading, and the system also shown reading for the input voltage and the output voltage. So now we set for 1. Okay, so shaft motor position and the output voltage still have no reading except for the input voltage. Okay, so if you okay, so I'm not going to show you all the simulation, but the explanation for this is that as the input angle increase, the input voltage also increase. So the shaft motor position and output voltage show no reading. So now I'm going to check for the increased step-by-step value of the attenuating gain from 0 to 10, and then set the input angle to 0. So the same. This one is constant 0, and this one 0. Okay, so no reading for shaft motor and input voltage and output voltage. Now increase the. Okay, so still no reading. Now I'm gonna skip and do the 5. Okay, still no reading. Still 10. Okay, still no reading. So the simulated value just now will be tabulated in the report. I think that's all for me. Thank you. Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azlin binti Niklin with metric number AE180012. So I'm going to explain about the activity 2 for number 6. So we need to um, measure the input voltage, output voltage, and also for the shaft motor position by changing the input angle for clockwise and anti-clockwise, and also we need to change our attenuator gain. So I'm going to show first for first input voltage, which is our input voltage is 5. This is for clockwise, and then our attenuator gain is 1, and then we can run our circuit, and then we can get the value for our input voltage is 3.056 volt, and our output is 2.4 volt, and for the shaft motor is for shaft motor position is 3.927, and then we can change our input angle, which is 5 negative 5, because we need to calculate for the anti-clockwise, and then we can run our circuit again. And so this is the value for input voltage, which is in negative, which is negative 3.056 for the input, and negative 2.4 for the output voltage, and for the shaft motor position also we get in negative, which is negative 3.927. And then we need to proceed this procedure by changing the input angle to 150 and also 360, and we need to change our attenuator gain to 5 and 8, but I already construct the procedure, and this is the whole value for the input voltage, output voltage, and also for the shaft motor for all the values input angle, which is 5, 150, and also 360, which is in clockwise and also anti-clockwise, and we also change the attenuator gain. And then we need to calculate for the average error. So after construct all the procedure and we calculate the average error, our average error is 11.78 percent. So that's all from me. Thank you.